Okay, we're still in exercise 69. Let me go back. I think I want to do problem number 2, right? Because I just finished number 1. And yeah, certainly reading number 2. And again, when I read a problem, someone says, I don't have access to the document. Again, if you watch those introductory videos, you'll start to learn how to get access to the document, including the original textbook. I hope a series on how to get the original textbook if you're interested. There's an advantage to having my book, though, and the advantage of having my book is there's a tremendous number, a tremendous amount of supplemental material in my book that goes well beyond Wells's capability at the time in typesetting. So what I want to do is I want to go to the whiteboard, but I'm going to be doing problem number 2, though, all right? So let me do that, and that was number 1. I'm going to do number 2 now. Let me write this down for you, and get my little pen out, and I'll put down number 2, all right? So we're doing problem number 2, and we're in exercise 69. So, certainly reading it, what does it say? It says the difference of the square of two numbers, right? So I know there's two numbers. So it says the difference square of two numbers is 260, and the sum of the number, oh boy, this gets really complicated, doesn't it? So again, let me read it again. The difference of the squares of two numbers. Let me write this down. There's x and y, and these are the two numbers, all right? So I'm going to say x is a number, and I'm going to say y is a number. I just don't know what the number is. All right, and then, it gets us the difference of the squares of the two numbers is 260. Now, by the way, when I write that down, and I'm going to write down x squared minus y squared, that's the difference between those two numbers. And the difference between those two numbers, just reading it, it says it's 260. And that's fairly simple to understand, by the way. But now I get that other part, and it says, and the sum of the numbers. Well, I think I can write that down. And the sum of the numbers, right? And the sum of the numbers, let's take a look at it. And the sum of the numbers is 13 fifths, right, of their difference. What's their difference? X minus y. So let me say that's my system. And the system's x squared minus y squared equals 260. And the other pretty simple linear equation, x plus y equals 13 fifths x minus y. And, certainly, I got to be honest with you, looking at it, when I say I'm looking at something, I understand that these things may be very difficult to look at. But the bottom line is, you know what? Visualizing a problem before proceeding forward may not be a bad idea, all right? And what I kind of know about this thing over here is, again, if you don't know these things, don't worry about it. One's hyperbole, one's a line, and I'm expecting 2 points of intersection, all right? So someone says, how are you going to do that? I don't know. I got to try something. And so what I'm going to do is, I like that substitution technique because it's probably the most intuitive. So I'm going to take the second equation. I can multiply both sides by 5, and you get 5x plus 5y. Don't be discouraged. We're just simply doing simple things. If a dead end, we'll back out of it. We'll try something different later. So I multiply both sides by 5, and now I can distribute the 13 across. What do you get? 13x minus 13y. And we have an answer key to look at, too. I want to emphasize we have an answer key to look at. And let me take a look at this. I got to be really careful, don't I? So I'm going to add 13y to both sides. That's 18y. And then I'm going to subtract 5x from both sides. And if you subtract 5x, you'd get, 8x. And I'm going to reduce that by dividing both sides by 2. So you get 9y is 4x. And I'm going to solve for y. And what's y going to equal to? 4/9 of an x. Now, so it says, why did you do that? The reason I did that, I want to take this now and plug it into the first equation. This is a technique of substitution. It generally works pretty nicely. So what do you get over here? X squared minus y squared. Well, what's y? It's 4/9 of an x. And we're going to square that, and that equals the number 260. All right, it's tough though. I realize that for some students, we're looking and say, I don't think I'll ever get to the end of that one, but I got to keep going. All right, what do you mean keep going? I got to do some arithmetic here. And what do you get? You get x squared minus 16x squared over 81 equals 260. Boy, that looks tough, doesn't it? And I gotta keep doing that. And I hate to tell you that. I gotta keep doing that. So what's going to be 81x squared minus 16x squared equals 81 times 260. Some people question me, why aren't you multiplying the 81 times 260? I don't know. It's too much work at this point. I'd have to do it later, by the way. So I'm gonna do the subtraction, right? So 81 minus 16. Let's see, that's gonna be 65, right? I'm not very good at arithmetic, by the way. I do make mistakes. And what I'm going to do now is I'm going to divide through by x squared. I'm sorry, by 65. I get x squared in my mind, by the way. 81, 260 over 65. Let's take a look. I got some work to do, don't I? And what I'm noticing about it is I'd like to reduce that number to make it easier for me. So x squared. And I think I want to divide by 3 first because it's easy for me to divide by 3. And 3 goes into 81 27 times. And 3 goes into 65. Oh, I'm sorry, I can't divide by 3. I made a mistake there. My mistake. 81. And I'm going to do the 5 into 260. All right, so 5 into 260. That goes 5, 25, and then you get 10, 2, so 52. And 5 goes into 65 13 times. Oh boy, it's going to get tough. X squared. And let's see, 81 and 52 divided by 13 is 4, right? Let's see, 40, yeah, 4. That's not bad. Gee, x turns out to be a really simple number. Plus or minus the square root of 81, which is 9, times the square root of 4, which is 2. So what's x equal to? Plus or minus 18. All right? Now, granted, somebody said, I have no idea what the original problem was. And that's what's so nice about having written words down, that I can always look back over it, and I know there's questions over there. And the question was, well, what's x and y? Well, I found 2 x's, right? So I'm going to say x could be 18. I'm going to write this as an ordered pair, x comma y. So x could be 18. And then the question is, what's the y? Well, you know what? I got a really simple equation to tell me what it is. And let me write that down for you. So if x is 18, what would I get? Y would equal 4/9 times 18. So 9 goes 18 twice, and 2 times 4 is 8. And what's the other one I got? I got minus 18. And again, if I went back over there and did this over here, instead of using 18, I used minus 18. What are you going to get? You're going to get minus 8. Now again, that's what my work would look like. You might say, I have a better way of doing it. And you know what? Maybe you do. Maybe you want to share that with me. I do want to point out that anybody shares an information with me that I deem to be more elegant than what I've done, I'll be more than happy to put it into the notes, including your name, by the way. Right? You could also create another YouTube saying, I got a better way of doing that. All right? No big deal. All right? People do things better than other people, and sometimes they think it's better. Sometimes I might think mine's better than yours, but that's a matter of opinion. All right? So I'm going to say we're done with number 2, and we need to move forward. Thank you so much for paying attention, though.